Let's talk about nonlinear systems. We already know systems of linear equations, and now we will talk about systems of nonlinear equations, and we will talk about techniques how to find a solution of such a system. But before we will do something else. We will check two examples in this video. One example, where does such a system may come from? What is an example? And in this video we will talk about a robot. A robot consisting of two arms, and you can vary the angles alpha and beta, and thus you will reach some position x0, y0, and what do you want is there's a given position and you want to reach that position by varying alpha and beta. The problem is of that kind. You can vary this alpha and you can vary this beta, and by doing so you will reach some position. Okay, and for given x0, y0, this one is given, you want to find alpha and beta, but how can you do that? This is not an easy question, and a very good idea is let's reverse the approach. Let's assume I know alpha and beta, and I ask the questions, where is x0, y0 for some given alpha and beta? The length of these two arms are given, and now we can do the following. We have here some alpha, and thus we can find the position of P. And then for some given beta, we subtract beta 1, and then we get some beta 2. And doing some basic trigonometry, we will find this position. That's what we want to do. And then we will revert back to find the angles, you will see. So let's do the analysis, and in the end we will get some nonlinear system. Okay, this is the situation. If you know alpha, and obviously we know L1, what can we do? We can find this position. This is the sine of alpha, and this is the cosine of alpha, or better multiplied by L1. So this is the position P1. Obviously, this is simple trigonometry. Okay, so next, beta 1. If we have alpha, we can calculate beta 1 by subtracting alpha from 90 degrees. And then beta 2 is beta minus beta 1. So beta 1 is given by that. And if you subtract beta minus this one, you will get alpha plus beta minus 90 degree. Okay, so that's the analysis to get beta 2, and now we will find that position. How can we do that? This length is given by, we know beta 2, by sine of beta 2 times L2, so this is this length. And this length is cosine of beta 2, but is directed to the negative direction of the y-axis, so it's minus cosine of beta 2 times L2. So P1 plus that is, this is P1, and this is this one. And so we get here this with the beta 2. But now our idea is the following. Instead of writing sine of alpha plus beta minus 90 degree, we want to write something else. And we know that sine of x minus 90 degree is minus cosine x. Yeah, check that this is true. This is some basic property of sine and cosine. Because this is true, we can write that to be minus cosine of alpha plus beta. And instead of writing that way, we can write sine of alpha plus beta instead of cosine x minus 90 degree, and the sign is also correct. So we have P2, this position is given by these two. And so knowing alpha and beta, we can calculate the position P2. Okay, and what will we do now? We will revert that, because we are not interested when knowing alpha and beta, calculating P2, but the inverse is what we are interested in, and this is, we know x0, y0, and we want to find the angles corresponding to that position. And so we can write it that way. We can write some unknown alpha, some unknown beta. This is the position, and this is the arm lengths L1 and L2. We have this equation and we have this equation. So we have two equations and two unknowns, alpha and beta, and so we have a set of equation, a nonlinear system. One, it's not linear because there's cosine of alpha and cosine of alpha plus beta. So we have a set of non-linear equations, and we are looking for the solution of this system. So this was the example. Where can such a system come from? Okay, we can stop the lecture here, but in this situation, you can find the solution in a different way. The normal way is, okay, given that system, let's apply some technique which gives us the solution of a system of nonlinear equations. But these are tricky. It's very tricky. Remember, an equation is tricky to find the solution. A set of equations is much more tricky. So you need initial values and all that stuff when you apply numerics. And to get rid of this question, it's better to not apply numerics if it's not necessary. And in this case, surprisingly, it's not really necessary. What can we do instead? This is the origin. This is the given position. So what can we do? We can calculate that distance d. And if we have this distance d, on top we have L1 and on top we have L2. So this triangle, we know every side length, and thus we can calculate the corresponding angles, obviously. So after having d, we can calculate beta, and we can calculate alpha 1. And using basic trigonometry, we can calculate alpha 2 on top, and thus adding these two angles we get alpha. So this is a succession of explicit calculations, and we will find, applying that, we will find beta and alpha, and we don't need numerics for this example. This example was an example where may a set of equations may come from. So how can we do the calculation? There's a law of cosines. I hope you remember, otherwise here it is. And now applying it for our situation, there's L1 and L2 and the given position. So let's calculate D. Please stop the video and do the calculation. What is the first step? The first step is calculating D, and this is quite easy. Unfortunately, I forgot to write on the paper. This is length 4, this is length 1, and so this is length square root of 17. And now let's calculate beta. These are the edges forming that angle. This is the situation here. And so it's L1 squared plus L2 squared minus D squared divided by 2 times the product of these two. And so let's plug in the numbers, and in the end you will get beta is 109 degrees. Okay, this is beta. So what do we do next? We will find the angle alpha 1 by again applying the law of cosines, and this is the calculation. Please check every detail. It's not completely obvious which number we have to plug in which position, but if you analyze the situation and analyze the kind of the law of cosines, you will find that these calculations are the correct ones, and in this situation alpha 1 will be 27 degrees. So next step, it's well, more or less the easiest one. So let's calculate alpha 2. We know D, we know this one, we know that one, and so cosine of alpha 2 is the length of this side divided by the length of that side. Okay, and thus we get alpha is 14 degrees and alpha is the sum of the two, so we get 41 degrees. For this example, we don't need numerics. In the later videos, we will talk about the numerics of a system, but if we can avoid numerics and find the solution in a succession of explicit calculations, we always prefer that. In this situation it is possible, in many other situations it's not possible. Okay, and we can check our solution. I need to check, I don't want to make a video and after publishing that video there will show up some error I always want to avoid, so I like to check my solution, and this time we can check graphically. Let's draw this line at this angle. Let's measure this length 3. Then let's at this angle, let's measure this distance 2, and let's check if this is position 4, 1, and it is. So everything was correct. Numerics is, sometimes I check when lecturing in a room with real students which can react to my questions. Numerics is like, and then they have to finish the sentence, and some of them said numerics is like bad food. What does he mean? He means the situation everybody of us needs food. We desperately need food. Most of us, it's no problem to get some food, so many of you think bad food is a very bad thing. That's not the point. If you're in the position that you need food, And if it's possible that it tastes well, then you will prefer the well-tasting food. But if there is no food available which tastes good, then you will be happy to find some other food. So the step-by-step solution is preferred, but this is not always possible. And if it's not possible, we need numerics, we need the bad food, because there is no better one, and that will be the role of numerics. Okay, so this was the story of our first example. In the next video we will see a second example, and after that we will talk about two algorithms which can solve a system of nonlinear equations, but there will always be the need of initial values, a guess of the solution we are looking for. So what we saw for one equation and one unknown, this will again be the point for systems, but we will see later in the following videos.